Welcome to Module 5, Lesson 23. We're going to continue using sample data to compare the means of two or more populations. And this is indeed the last lesson of Module 5. Okay, following this lesson, you will complete your end of module assessment. All right, so so with no further ado, let's move forward. So what we've been talking about for this entire ending half of Module 5, we first talked about probability, but more or less what we are talking about now, or we have been talking about, has been an introduction to statistics. Okay, and what statistics does, statistics is involved in making decisions concerning populations, and those populations, more or less, mostly, are people. Okay, when a new drug is being tested for its what we call efficacy or its usefulness, populations are compared. There's comparisons made between groups receiving the medication and those not receiving the medication, and those groups are then compared via many different statistics. And what you're seeking always is a difference between those two populations. You want there to be, ultimately you would like there to be a difference in the way the people receiving the drug react than those who did not, okay? Because, and of course you want it to be favorable. You want them to be getting healthier. You want their cancer to be disappearing, or whatever the case may be. But every statistical study starts off with this idea, and we talked about this, I mentioned this a long time ago, it's called the Null Hypothesis, that they are not different. They are not significantly different, whether you get the drug or you don't get the drug, for example. Okay, you start off with that premise, but then you try to prove that incorrect. Okay, you try to prove that yes, indeed, there is a difference. So you're always trying to see if there is a difference between two populations. Okay, or Anyway, that's what we are interested in, and this all gets much more formal in high school classes and beyond, okay, especially if you're going to continue in a field, maybe the medical field, mathematics field, business world, okay, you'll be more involved in statistics, okay. For now, for our purposes, we are relying on the more informal. Okay, so it's not so formal. We're not getting into the really complex formulas. As complex as they look, honestly, they are not really all that complex. It's kind of hard to understand or try to imagine the person who first came up with some of these processes, and a lot of these processes are all intended to more or less prove or disprove the validity or the reliability of the results that you get from a study. Okay, but we have been looking at the more informal because basically what we have been talking about is this idea that a difference between sample means is considered meaningful if it is greater than what would have been expected just due to sampling variability, okay? And again, we've talked about this idea of sampling variability. You take one sample of people and you compare them against another sample of people, and you're always going to have some difference. There's always going to be a variability. That is natural. That is something you just deal with in statistics. But what we try to prove always is it meaningful? Is this difference? You hear again, here's this difference idea. is the difference between these two samples, again, let's talk about a new drug, is the difference between the way this group that was getting the drug responded than this group that was not getting the drug responded. That difference, is that meaningful beyond sampling variability, beyond the fact that maybe some of the people who were getting the drug were healthier to begin with? We don't know, because these samples are random, they're based on certain criteria, but you can never be sure that they are, these samples are perfect, because you can't clone. If we could clone a group of people and have them taking the drug and then their clones not taking the drug, then that's maybe a perfect world right there. But, not a perfect world, because cloning people is, in my mind, a bad thing. But, anywho, you get my drift, okay? Now that's pretty nebulous here, this idea of greater than what would have been expected just due to sampling variability, okay? So we've tried to take it another step, and we have looked at the MAD, mean absolute deviation. And like I said to you when we first started talking about this or utilizing this tool, I had not heard of it myself beforehand. Okay, the tool or the measurement that I've used in statistics has basically been what's called a standard deviation. So I missed out on this. Anywho, yeah, this MAD, it quantifies this meaningfulness. Okay, so it puts a number on this meaningfulness, and very simply, what the MAD tells us, the bottom line is if two sample means are separated by at least 2 MADs, then it is reasonable to conclude that there is a difference between them. Okay, now a difference between them that that is not explained simply by sampling variability, okay? So it's saying that this difference that we see between men and women in their sleep time, for example, if we had MAD at 2 or above, then we would say, okay, it is meaningful. If it wasn't, if there was only one mean absolute deviation that separated the two, then we would say, we can't conclude that. Now, that doesn't mean it's not meaningful. It just means that we cannot safely conclude or reasonably conclude. And that's what it's all about, as being as reasonable and as careful as possible. Again, we are never interested in being perfect, because it just is not going to happen. Okay? All right, so let's jump into example 1. And let's get this last lesson over with. Okay, so in the previous lesson, in lesson 22, we described how far apart the means of two data sets are in terms of the MAD, mean absolute deviation. Okay, there it is again. I'm not going to forget that. A measure of variability. In this lesson, you will extend that idea to informally determine when two sample means computed from random samples are far enough apart from each other to imply, again, all these words, reasonably conclude, imply, that the population means also differ in a meaningful way. Okay? Recall that a meaningful difference between two means is a difference that is greater than would have been expected just due to sampling variability, which I just mentioned. Okay, so here we go. Let's jump into this texting. Example 1, texting. With texting becoming so popular, Linda wanted to determine if middle school students memorize real words more or less easily than fake words. For example, real words are food, car, study, swim, whereas fake words are steak, fanwo, seeker, I don't know what these words are, but anyway, you see them there. These are maybe more familiar to you. These might be actually little abbreviations little text abbreviations. I don't quite get them. Anyway, she randomly selected 28 students from all the middle school students in her district and gave half of them a list of 20 real words and the other half a list of 20 fake words. So here we go. We have two populations. One is getting the real words, one is getting the fake words. Okay? And it's a population of 28 students, and I guess she's going to split up 14 and 14. Okay? So how do you think Linda might have randomly selected the 28 students from all the middle school students in her district? How might she have done that? Well, as we have learned, there are random number generators available to us online, which I am just ecstatic about. I'm definitely going to find a way to use one of those in the future. That Rossmann chance random number generator. You could just assign a number to all of those students, and then go ahead in your random number generator, generate these random numbers, and that way pick your students. And of course, you could use one of these random number tables that we have seen. We haven't used them in this module a couple lessons ago. I just thought it was too tedious, and I just think the random number generator is the bomb, so I use that. But anyway, those are some ways. I mean, she could put slips of paper with, numbers assigned to all the students and pick them out. Every student actually within a district, after taking testing, is assigned a number. It's called an SSID. Could throw all those into a bag and pick from the hat. Okay, there are many ways to be random, I guess. So why do you think Linda selected the students of her study randomly? Okay, well, this idea of random assignment is done to help ensure that groups are similar to each other. Okay, so this randomness is randomness is just very important. Okay. Okay, so random sampling better ensures, I'm going to say better because it never ensures anything, better ensures that groups are similar. Okay, groups are similar, groups are diverse. It's not a guarantee. Okay, there is no guarantee, but it's just a better insurance. All right. So, continue on here. She gave selected students 1 minute to memorize their lists, after which they were to turn the lists over, and after 2 minutes, write down all the words that they could remember. Okay, so this is her test, and really fun stuff, and maybe some things that you might want to do. Maybe you could even do this, I don't know, at your church or at your some club or with the soccer team or whatever. But anyway, afterward, they calculated the number of correct words that they were able to write down. Okay, so do you think a penalty should have been given for an incorrect word written down? Explain your reasoning. And again, whether you think so or not, that is fine. Again, in the classroom, we could take a position and argue whether a penalty should be given, yes or no. Anyway, that's just more or less a question to have for debate in class. So we'll just skip that. Boom. Okay. So here we go. We have, let's get into this thing, and let's start crunching some of these numbers and such. So suppose the data, number of correct words recalled she collected were as follows. Okay. Oops. So in this here, we're not going to do any actual collection, but were as follows here. Okay, for students, given the real words, there they are. There are the scores. Okay, so 14 students, and that's how many they recalled, or they recalled correctly. And then for students, given the fake words, that's how many they recalled correctly. Okay, so there is our data. Okay, our data. All right. Again, let's go ahead on the same scale, draw dot plots for the two data sets. And I think I'm safe to ask you to do that yourself before you see mine. So if you would go ahead and do that. Create two dot plots, one on top of each other, using the same scale, and have those numbers plotted out with dots. Okay, so go ahead and do that. Pause. Go ahead and do that, and come on back. Okay, well, here we go. Here's what my two dot plots written using the same scale looks like. Okay, and hopefully yours looks exactly the same. That would be the ultimate. So from looking at the dot plots, here I'm on number 2 here. I'm looking at the dot plots. Write a few sentences comparing the distributions of the number of correctly recalled real words with the distribution of numbers of correctly recalled fake words. Okay, so in particular, comment on which type of word, if either, that students recall better. Okay, so go ahead and write a few sentences down. It's good practice to explain what you see, to really interact with data distributions. Okay, and specifically go ahead and comment on which you think you can indeed safely say that they recall better. Okay. Okay, so let's see what you wrote here. Well, if I'm looking at this data, and if I'm going to, in particular, comment about which type of word they can recall better, I would have to say real words. As I see, it's most definitely, the real word distribution is relatively symmetric, because I can actually pretty much draw a line about right here, and there'll be, there's 7 on this side, 7 on this side, and it's pretty symmetrical. There's not a lot of groups here. There's only one here, like kind of a group of 3 that remember 12, but more or less kind of centers around 9 or 10. Whereas these fake words, not a lot going on down in the larger number recall. Okay, but it's very much skewed to the left here. So if it works out that we get a decent MAD, so if we get a decent MAD, a decent mean absolute deviation, I would say we could then say real words were better, were recalled better. Okay, if we get that. Okay. But from looking at this data, looking at these two dot plots, it looks to me, even though there is some overlap, I wouldn't say there's a great deal of overlap. You have, like, right in here, got some overlap within that range. But otherwise, it seems pretty clear to me that real words were recalled better. And sorry, but just to use common sense, it seems to make sense to me. Okay, so Linda made the following calculations for the 2 data sets. Okay, so she went ahead and calculated the mean, both. Okay, and then she went ahead and calculated the mean absolute deviations of both. And right away, hopefully you can see, let me get those because that's a little bit disturbing. You can see that those MADs, those mean absolute deviations, are very similar. Okay, which is good. Okay, but the means are pretty different. All right, as you can see the mean for the real words recalled 9.43, and then fake words 5.36. All right. So in a previous lesson, you calculated the number of MADs that separated the 2 sample means. Remember that we used the larger MAD to make the calculation. If the 2 MADs were not the same, they're not the same, but they're pretty darn similar. How many MADs separate the mean number of real words and the mean number of fake words recalled for the students in this study? Okay, so why don't you go ahead and see if you can remember what to do with these numbers, and come on back and check in. Okay, so let's see if you remembered what to do. First step would have been to find the difference, of course, between the 2 means, and that was 9.43 minus 5.36, and that equals 4.07, and that is going to become our numerator. Okay, and then we're going to take the larger of the mean absolute deviations, and put that as our denominator because we're trying to find out how many of these are in this, okay? How many mean average deviations are there in that difference between the two population means, okay? And what we get is 1.78. And right away, hopefully, you see that this number is indeed less than 2. Okay, less than 2 because that is our guide. All right, so in the last lesson, our work suggested that if the number of MADs that separate two sample means is 2 or more, then it is reasonable to conclude that not only do the means differ in the samples, but that the means differ in the populations as well. So what we're able, quote unquote, to do is to then extrapolate. Okay, so we're going to say that we can say that the means differ in the populations as well. Now, not just in the sample, these two samples of 14 students, but also the entire population of all of the children in this school, okay, wherever they took this from, okay? So that's what it is. So the difference is enough to help us feel like we're reasonable in making that inference, okay? If the number of MADs is less than 2, then you can conclude that the difference in the sample means might just be sampling variability and that there may not be meaningful difference in the population means, okay? Despite the fact that we looked over here and we can see, look at how many of these the real words people were recalling, and then look at all these on this side. So they're really pretty much clearly on two different sides of that dot plot. But despite that, because the MAD, the mean average deviation, there were only 1.78 MADs between these, between the difference in the means, we are going to have to, what we say, accept the null hypothesis, okay? And again, I don't want, I'm not going to, well, I won't write that down. And that idea is that, yes, indeed, Linda would have to conclude that the average number of real words that all middle school students in her district would recall might be the same as the average number of fake words that they would recall, okay? Which is kind of hard to get your mind around, but is the world of statistics, okay? Despite the fact that looking at this and this says, wow, boy, pretty clearly they recall the number of real words better than they do fake words. We have to reject that idea, okay? Because there is just too great a possibility of sampling variability, which has come to be seen via that number, okay? And that is really why statistics can indeed be some tricky stuff for kids. What seems pretty obvious is not when you look more closely at data. Okay, well here is example 2. We have Ken, an 8th grade student, was interested in doing a statistics study involving 6th grade and 11th grade students in his school district. He conducted a survey of 4 numerical variables and 2 categorical variables, grade level and gender. His Excel is a program from Microsoft, Excel population database for the 265 6th graders and 175 11th graders in his district has the following description, okay? So when you do an Excel spreadsheet, okay, those of you who may know, you have a, actually let me go ahead and get an Excel spreadsheet and just show this to you. Okay, so here's a picture of, I just took a screenshot, actually I just took a photo of my my other computer. You can see this is an Excel spreadsheet. This is Excel 2010, and so what you do is you actually put your data into these, into these cells, these boxes here, and and then you can generate all kinds of graphs and reports. Hugely important in statistics. You can use this actually, the data here, this data tab here. You click on there, and you could do all kinds of stuff manipulating the data that you put in it. Okay, so that's what, when they refer to Excel, that's what they mean. Over here, these are what they're talking about here. Column 1 here, they have an ID, all right? So they're going to have ID numbers for 440 kids. Okay, so 1 to 128 are the 6th grade females, and then they separate the 6th grade females from the 6th grade males, and then the 11th grade females from the 11th grade males. Okay, the next field is going to be the number of minutes they text, and then respond to the computer screen stimulus, total number of hours spent doing on homework, a number of hours of night, 1 decimal place. Okay, so this is the data that they're going to be looking at, entering into this Excel spreadsheet, and then Excel is going to spit out all kinds of data, statistical analysis for them. Okay, so Ken decides to base his study on a random sample of 20 6th graders and a random sample of 20 11th graders. Okay, so there are his two populations here, from the 6th graders and from the 11th graders. Okay, so there's a random sample from each of those populations. Okay, so we're going to compare two populations. One population are all of these 6th graders, and then the other population, all these 11th graders. Actually, in fact, how many of each? I know we'll get to all these charts in a second, but what was there? Got 120, 265 of each. Is that right? 265 6th graders, and then it looks like, yeah, 265 11th graders. Okay, we'll get back to all that later, like I said. Okay, so the 6th graders have IDs 1 to 265, as you just saw, and the 11th graders are numbered 266 to 440. Okay, so advise him on how to randomly sample 20 6th graders and 20 11th graders from this data file. Yes, we're going to go ahead and advise him on how to randomly sample 20 6th graders and 20 11th graders from his data file. Okay, let me show you this data file. And oh, I'm sorry, I already showed you all of that. Didn't mean to. But anyway, you'll figure out what that means in a second. But here's his data file. Here is all of this data. Okay, and here are, you can see the ID numbers here. Okay, if you guys want to go back and use this for any reason, I can't imagine why. But anyway, you can see there's the ID number, and then the here is the minutes here texting, and then we've got the reaction time that they test, the homework they did, and the sleep that they get. Okay, so all of those are there, and you can see all of these here are going to be, all of these are 6th graders because they go all the way through to, so this would be, I think, our last 6th grader right here, so our last 6th grader, 265, and then begins the 11th graders would be after that. But again, you don't really need to know this. I'm just explaining what all of these are. But these are all of our 11th graders, all their data. Okay, and again, don't really need to know any of this, but I'm showing you anyway. Okay, so there's all of that. So a great way to do this random sample, or figure these random samples out, if I was going to go ahead and advise him, hopefully you guys would say, hey, try the Rossman chance. Applet collection, generate random numbers. Okay, so we could use this. And again, you know how to use this. If you feel like using this and doing this on your own, you can. Most likely you don't want to, because you just want to get this module over. And I want that for you as well. And it's more important that we just discuss these findings. Okay. All right, so we go ahead and do that. Bless the people who put this together, because they did all of that random number picking already for me here. So they picked these numbers here. Okay, for the 6th graders, 26th graders, there were the random numbers, and then here were the random numbers for the 11th graders. And you know how we would do this. If we were in class, we might do a little bit of this, but again, it would become just busy work. If we did, we circled this, and there we see that's number 231 for a 6th grader. If we go back, we would see that 231 was right here, okay? And then we're talking about the hours of homework, and there's his is 8.5, and you can see that that appears right here. That must be him right there, okay? That 231 random sample fella, okay? All right, you see they didn't actually put them in order, okay, order them. Least to greatest, which I like to do on the Rossmann chance when you're going to have sort. I always try to, I don't know why they have no as a default, I always try to say yes to sort the results, okay? And if they did, this would have been sorted, but it's not. But anyway, that is very, very much besides the point. There are the random numbers for the 6th graders, and then here are the results down there. Actually, I'll just turn the page here, and you can see here are, wow, I have like done everything. I got to get rid of some of this stuff, Frank. Okay. Anywho, here we go. Here are the times for 6th graders, grade 6 up here, and grade 11. All right, so what we are going to do, don't do that. Going to do now is create dot plots. Let me get rid of that. You know you can always do this again if you want to. You can always look at it again, but I'd like you to create your own dot plot. All right. So if you put it and make a dot plot on the same scale like I have right here. Okay. I went from. I mean, you could do it any way you see fit. In my teacher's guide, they did it in a real strange way. They really stretched out the scale, which I thought was kind of odd. So I just did it this way, 2 through 14, because I knew my smallest number was in the 2s and the largest number was nearly 14 or 13.2. So I looked at those two extremes. Again, when you're creating 2 dot plots that are going to go together, you have to look at both sets of data before you can decide on this scale. Okay. Anywho, go ahead and create your dot plot using this data. If you don't want to do that, just stick around because I'm going to hit the button and populate my dot plots. So you better pause now if you want to do it yourself. Okay, here we go. All right. There we go. Populating 6th grade. There we go. Populate 6th grade. You can see this kind of wide variety. You can see where they stretch from 3 up through 9, about 9.5. What are the two extremes here? It's about 9.3. 2.9 to 9.3 are the extremes. Very, very symmetrical. Okay, we could just put a line right down the middle of those 2, 4, 6. Yeah, there we go. And we can see, we could guess that our mean is going to be right around there between 6 and 7. Looks maybe closer to 7. Okay, if we were to guess or estimate a mean there. Populate grade 11. And again, now you can see, again, a relatively symmetric distribution, shifted to the right, of course, and which would make sense, as 11th graders would tend to have more homework than 6th graders. Okay, and again, if we were to estimate maybe a mean here, 2, 4, 6, 7, probably around 10 or so, right? Around 10, maybe a little bit more, probably right of 10. Between 10 and 11, I'm going to estimate. Okay. Okay, so letter D here. Again, we've done a little bit of this already, but from looking at the dot plots, list some observations comparing the number of hours per week that 6th graders spend on doing homework and the number of hours per week that 11th graders spend on doing homework. Okay, and some of those observations we saw generally tend to see that 11th graders put more hours in. We can look over here again, and we can see there is some significant overlap right here. We can look, we're overlapping right in this area. Okay, quite a bit of overlap in between. That looks like 7.5 to 10. Quite a bit of overlap, but still very obvious that the 11th graders seem to have more homework. 6th graders between 6 and 7, closer to 7 probably, and 11th graders between 10 and 11, probably closer to 10. Okay, so we are going to, what I'd like, actually, I won't have you do it. If you wanted to do it, you could, but I mean, you're going to do it probably in your problem set, so I'm not going to belabor this anymore. Let's just go ahead and use the means that I've calculated and the MADs as well. Okay, so what we're trying to do here, we're going to calculate the mean and MAD. Again, remember that's mean absolute deviation for each of the data sets. How many MADs separate the two sample means? And again, we're going to use that larger MAD. So let's go ahead and populate that section there. Our mean data, or means from the two populations, we have grade 6 at 7.055. That was the mean from that random sample of 20. Okay, and again, we've taken it from a population of 265 and picked a random sample of 20. Okay, so more or less, a little bit less than 10%, 18% of the entire population. 11th grade, you can see the mean there is 10.32. Again, we look and we say, oh wow, the mean 11th grade is larger, therefore this is looking pretty convincing argument that 11th graders have more homework than 6th graders or do more homework than 6th graders, but we have to be careful because we need to look at any sort of variability, okay? And variability, and here's our variability, the MADs, the mean absolute deviations for both of those, 6th and 11th grade, and they differ. Interesting that they differ somewhat substantially, more so than we've seen in the past, which may bode well or not so well. We'll see. Okay, so now calculating, we're going to go ahead and calculate the to see how many mean absolute deviations separate the two sample means, which are 7.055 and 10.32. How many of these, and again we're going to use the larger one, okay, so we do, that's the rule. How many of those are in that difference? And then we do here, find that difference first. So we have a difference of 3.265, and that becomes our numerator. And we're going to divide that by the larger MAD, that actually comes from the 6th grade population, 1.274, and what we get is 2.56. And you're smiling, I'll bet, because finally, well, not finally, we have had it before, but last time we didn't. But we do have a relatively substantial difference here. Number of mean absolute deviations that separating those two means, 2.65. And therefore, Ken recalled Linda suggesting that if the number of MADs is greater than or equal to 2, then it would be reasonable to think that the population of all 6th grade students in his district and the population of all 11th grade students in his district have different means. So, what do you think Ken should conclude based on his homework study? Go ahead and think about that, jot some ideas down, and come on back. Well, yeah, it's pretty simple. Because of this confirmation that we got from this 2.65 number, we can pretty much safely conclude, or reasonably conclude, that an average 11th grader spends more time doing homework per week than the average sixth grader. Okay, so we can actually make that claim because we saw it in a few places. We saw it here in this raw data here, the mean from both of those populations of 20, random samples of 20, and then here we have two mean absolute deviations that separate these two means here. Okay, and because of that, there is enough of a difference that we can safely conclude that this difference is due to something other than plain and simple sample variability. Okay, so in closing this lesson, in closing Module 5 forever in your life, Grade 7's Module 5, of course, to determine if the mean value of some numerical variable differs for two populations, you take random samples from each population. Okay, our first primary thing to do is to take random samples from each population. It is very important that the samples be random. Okay, if the number of MADs, those mean absolute deviations that separate the two sample means, is 2 or more, then it is reasonable to think that the populations have different means. Otherwise, the population means are considered to be the same, and this idea is really, like I told you before, what all statistical studies start with is that null hypothesis, is that there is no difference. Okay, and the null hypothesis means no difference. Okay, but what we are always trying to do in statistics is you're trying to reject the null hypothesis, and the only way you can do that is if you, and in this case, we had a MAD of 2 or more. Okay, separating the two sample means. Okay, so you start off with this idea; they're considered to be the same, and then you work actually back to rejecting that idea and saying that no, there is a difference. And the way we found out, one of the tools were these mean absolute deviations. Okay, I think I said that term enough that I am not going to ever forget it. Oh, I probably will. Okay, well, good luck on your end of module assessment. Any questions, please do not hesitate to call or email.